Hello everyone, this is Ankit from Kailasha Foundation Funnel Learn Portal. This is your fourth and final lecture of probability that was pending for long. And in this lecture, we will study the mean and variance of uh, random variable probability distribution. Okay, mean and variance of probability distribution. So in the previous lecture, we learned about random variable and what is a probability distribution. We learned about random experiment and all. Now, if we are given with a probability distribution, then what to do? So let's see. Mean and variance of a probability distribution. Okay. So x is our random variable. Px is its probability. It can be written in following ways. This capital X is the name and small x is the value. Okay, and we can write anything x or small x, or we can also write in this way. Okay, the value of capital X is x. So x, this is our variable. This is the name of the variable that we use to denote that. In the same way, we can write this, or simply we can write this also, or we can write fx. Okay, when you write fx, you get a glimpse that it is just like the frequency distribution that you studied in the first chapter of statistics. That was a statistical description of that data, in which you were learning about frequency distributions. So x and f was the format of the table, where you did x into f, and then you took sigma xf and sigma f, and then you found mean and other things using this. Okay, now treating this table, this probability distribution that I told you about in the previous lecture, that if the list of the values of x along with the probabilities, that is px, we can also write fx. Probabilities that are denoted with px, we can also write fx. Okay, so the this list, this table is called a probability distribution. Also, if we make a graph of this, that graph will also be called probability distribution. Okay, so anything representing this probability distribution in any manner, textual, tabular, or diagrammatic, is a probability distribution. Okay, so with this probability distribution, we will do the same thing what we do with a normal frequency distribution, a simple frequency distribution, to find mean and variance. Okay, now say there's a probability distribution in which there are values like 0, 1, 2, 3, 4, and the probabilities are 0 0.1, 0 0.2, 0 0.3, 0 0.15, and 0.25. Okay, so the total is obviously 1. Okay, the total is obviously 1 because the sum of probabilities in a probability distribution is definitely 1. Okay, because when you list a random variable, you list all possible values of the random variable. That means nothing is left, and hence all probabilities are listed. Everything is mutually exclusive and exhaustive, obviously exhaustive. So when it is exhaustive, then sum must be equal to 1 because nothing is left behind. Okay, so now we will do x into f. This is 0, this is 0 0.2, this is 0 0.6, this is 0 0.45, and this is 1.0. Okay, let us cross check for calculations, because a few students marked our a couple of mistakes in our all in our videos, a few videos. Okay, uh, out of our 500 videos, there were one or two mistakes in a couple of videos. Recently, a few students pointed out that I appreciate because human errors are possible. So I told everyone to notify that, and I like that. So that's why we are cross checking that there is no calculation mistake right now in this one. So 0 into this is 0, 1 into this is okay, 2 into 0.3, correct. This is 0.45 and this is 1.0. We did x into f just like we do in frequency distribution. So probability distribution you have to treat just like frequency distribution. Okay, you have to treat a probability distribution just like a frequency distribution. What you do in a frequency distribution, mean x bar is equal to sigma xf by sigma f, right? In probability distribution, the same mean will be denoted by mu. You can also write x bar, but appropriate notion is mu, and mu is equal to sigma x into px, that is fx also. And for convenience, people write f, so sigma xf again by sigma f. But sigma f is always equal to 1, so no need to write this one. That's why this formula looks way better than the formula of probability distribution. Okay, so mean of a probability distribution is sigma xf. Mean means what is average? But average in terms of a random variable has a very significant meaning. It's not only average, it's not only mean. Okay, see, there are these many values possible of the random variable. Okay, our random variable is x. Out of some random experiment, there's a random variable x that can assume these values 0, 1, 2, 3, and 4. No other value is possible. Okay, okay. So what do we expect that if we perform the random experiment once, then what is the most expected value that should occur? Okay, your first preconceived answer will be that okay, 0.3 is the highest probability, so 2 is the most probable value. But it's not so, because there are a few more values with close probabilities also. This one. Okay, so expected value will come out using the formula, and that expected value is the mean itself. So the mean is actually not only mean but also mean, which we call mu, or expectation of x, that we write e bracket capital X. Remember that you can write only capital X here. You cannot write small x, because capital X is the name of which you are finding the expectation. So expectation of capital X. Okay, so mean or expectation of x, these both of these are the same things. Okay, this is equal to sigma x into f. Okay, that's clear, I guess. Now we add these. Sigma xf is equal to 5, 2 and 6, that is 8 and 4, 12, 2.25. So 2.25 is the expected value. 2.25 is the expected value. See, it's not 2. Uh, yes, it is statistics. Yes, it has limitations. And yes, you have a valid question right now in your mind. You have a valid question right now in your mind that 2.25 is not a possible value. 2.25 is not a possible value because 0, 1, 2, 3, and 4, these are the possible values of the variable. Then how come this is 2.25 and we are calling it that it is the most expected value? Okay, so it says it says that the value obtained will be as close to this as possible. Okay, that is the expectation. It is not guaranteed that it will be the value. It is expected to be the value. The value can also be 0, the value can also be 4, but the most expected value will be close to this value. Okay, the most probable value, the expected value will be close to, will be a valid value close to this value. Okay, so 2.25 is the expectation by formula. 2.25 is the expectation by formula. It is not the actual expectation, because 2.25 is uh, not a possible value. Okay, but yes, in exam, if it comes that what is the expectation or what is the mean, we will write this one only, because this is the definition. This is what the definition says. Okay, for understanding, we have to understand that though it is not possible, but it is close to the expected value. Okay, so mean and variance of a probability distribution, we first studied about mean, and the mean comes out to be sigma xf. Okay, in the in the frequency distribution, our value, our formula was sigma xf upon sigma f. In the frequency distribution, this was the formula, but keeping the same formula, this value is equal to 1, so dividing by 1 we get the same thing. So this is the uh, formula simplified. This looks better than the original formula. Okay, so the formula is not changed, but it is simplified. Okay, this is the mean of a probability distribution. Now we will see variance. Variance x f xf x square f. Okay, what was the variance in a frequency distribution? Variance, not root. Root was for standard deviation. Okay, variance of x in a frequency distribution was sigma x square f upon sigma f minus mean square. Okay, so it will be actually sigma x square f upon sigma f minus sigma xf by sigma f whole square. Okay, so it is actually in our probability distribution, this one will be 1, this will be 1, so it is sigma x square f minus sigma xf whole square, because multiplying or dividing by 1 doesn't make any change. Okay, what is sigma xf? Sigma xf is actually expectation of x, so square of this. And what is sigma x square into f? So expectation of x is sigma xf, expectation of a is sigma af, expectation of b is sigma bf, expectation of k is sigma kf, expectation of x square is sigma x square f. So what is this? It is expectation of x square. Okay, this is variance of x. This is the formula which many of the students do not understand. Actually, this is the formula, this one. So this you have to remember for calculation purpose. But for direct answer of objective questions, you have to remember the formula, this one. Okay. For calculation, this one, and for direct answer for objective questions, this one. Okay. So these two are the formulas. So what do we need? We first have to find the mean. What is this actually? Let me tell you. The formula is sigma x square into f minus mean square. Okay. So this is x, this is f. These two will be given. You will find x square easily. You will then multiply by f. So you will get x square f. Now you will do sigma x square f here. Here you will put the value. Okay. Here you will put the value of sigma x square f, and mean you have already found. I have told here. Okay. So this is how you deal with a probability distribution, expectation, variance, mean, etc. Okay. Now we do the examples of the chapter. This is the notion of a probability distribution, x and p. This is the probability distribution of head when coin is tossed thrice. Okay, so when coin is tossed thrice, head can come 0 times or once or twice or thrice. So number of heads can be 0 or 1 or 2 or 3. The probability of this one, that is TTT, it is only one time out of 8 options, so 1 by 8. Uh, and this one can occur thrice, this one can occur thrice, and this all three heads, that is HHH, this is also 1 by 8. So this is the X and P table. Yes, this is horizontal. I have told you like this. That's not a problem. 0, 1, 2, 3, and it is 1 by 8. This is 3 by 8, 3 by 8, and 1 by 8. So not a problem. This is the probability distribution. When X and P are organized in a table or in a graph, that is called a probability distribution. And again, I am telling you, see, the total is 1. Okay, 1, 3, 3, and 1, that is 8 by 8. 8 by 8 is 1. So points to be noted are the probability is greater than or equal to 0 for every value of x, and the sum of the probabilities is 1. Okay, this is how we write, and there is a misprint, and this is actually p. Capital X is equal to this small x is used for values, that is actually 1, 2, 3, 4, etc., and capital X is the name of the variable. So whenever capital X is written, you are dealing with the name of the variable, Ram or Shyam or height or weight and etc. When small x is written, you are dealing with actual values, that is 1 or 2 or 3 or 5.7 etc. Okay. So whenever it is written capital X, it is height, weight, length, breadth. That means variables, the name of the variables. Whenever small x is written, you are dealing with values, that is 5.3, 6.9 etc. Okay, so remember, you have to mind the difference between capital X and small x in this chapter. Okay, this was a misprint here. This has had to be small x, that I corrected. Okay, and when the probability distribution function is continuous, that we will learn later in the theoretical distributions chapter. uh, when the probability distribution is continuous, then instead of sigma we use integration symbol, that you don't have to actually perform integration. Okay, don't be frightened of this, that you have to do integration in this chapter. Not at all, not even a glimpse of integration there will be. You just have to keep in mind that instead of sigma, the symbol becomes integration when the distribution is continuous. Now I'll tell you the difference between discrete and continuous. Though I told you already, I'll tell you again right now. See, the number of heads after 0, it is directly 1. It cannot be 0.5 heads, 0.6 heads, it cannot be 1.27 heads. After 0 it is 1, after 1 it is 2. The values in between are left because those values are not possible. Okay, so it is discrete. But when we talk about height, so between 5.2 and 5.3, even there's a possibility that the height is 5.24 or 5.25, and even between 5.24 and 5.25, there's again the possibility of 5.243, 5.244, etc. Okay, so any value in between is possible always. So that is a continuous variable because your height didn't jump from 5 feet to 6 feet. Okay, actually it was 5 feet at a time, and then 5.0000 something, and then 5.1, and then 5.2, gradually, not suddenly. It didn't jump anyway, it didn't skip values in between. It gradually increased from 5 to 6. Okay, so it is continuous. So height is a continuous variable. Number of something, number of people in a room, number of heads, number of tails, this is discrete. Okay, weight is a continuous variable. Okay, so whenever we talk about continuous variable, the distribution automatically becomes continuous, and for continuous variable, just to answer objective questions from the options, we will choose the option which involves the integration symbol, that from beginning to the end, the integration of fx, that is probability, is equal to 1. Just like sigma fx was equal to 1 in discrete, just like sigma fx was equal to 1 in discrete, in the same way integration of fx will be equal to 1 in continuous. Integration of fx in continuous will be equal to 1. Okay. Now, what we already talked about a few minutes ago, expected value of a random variable mu, that is mean, ex, that is expectation, and again there's a printing error. It is actually e of capital X. They don't know how to write, or the printing guy did these mistakes. These are blunders actually. Okay, this can never be small x, it is capital X. Okay, so expectation of x, this is equal to sigma px. Okay, and expectation of x square, again small x they have used, it is capital X, it is sigma px square, that I told you sigma x f, and this one I told you sigma x square into f. Okay, now variance of x, this one variance of x is sigma x square minus mu square, that I told you, this one minus square of this, sigma x square f minus mu square. Mu, you know how to find out, this one. Okay, the positive square root of variance is known as standard deviation. So when you have variance in your hand, you already have the sigma also, because sigma square is sigma x square f minus mu square. So you already have sigma also, because you just have to put a root symbol over this. Okay, this is standard deviation. Okay, now we will take a look at solved example. An unbiased coin is tossed 3 times. Find the expected value of the number of heads. Expected, that means mean. Okay, expected value, that means mean of number of heads. Just keep this in mind. You have to find mean of what? Mean of what? Number of heads. Okay, so your x is straight away number of heads. Now just take a look, what did you do? What was the experiment actually? Experiment was that the coin is tossed 3 times. And what you have to find? Number of heads. The coin was tossed 3 times. What you have to find? Number of heads. So out of 3 tosses, what are the possibilities? Head can occur 0 times, or once, or twice, or thrice. So these are the values of x. Now p, or for convenience let's say f. So the sample space is HHH, HHT, HTH, HTT, THH, THT, TTH, TTT. Okay, so 0 heads, only this one is the case, 1 by 8. Okay, 1 head, this one and this one, 3 upon 8. Again this one also 3 upon 8, and this one is 1 by 8. So what is mean? Mean is sigma xf. We will just do sigma xf. Xf is this is 0, this is 3 by 8, 6 by 8, and this is 3 by 8. Total 12 by 8. that is 1.5. Okay, so 1.5 is the expected number of heads. So what do I tell you? Actually, you just think of it yourself. Okay, you toss a coin 3 times. Just let me change the question. You toss a coin 100 times. The probability of a head is 1 by 2. Obviously, how many times will you expect heads to come? Tell me. You toss a coin 100 times. How many times head will occur? What is the expectation? Actually, what will happen, you don't know. Actually, it is possible that head occurs, say, 80 times or 90 times or even 100 times. That is rarest of the rare possibility, but that is also a possibility. Okay. But what is the expectation? When you toss a coin 100 times, obviously you will think that head will occur 50 times and toss will occur 50 times. Equally likely events, so equal probabilities, right? If you toss a coin 10 times, then 5 and 5. Okay. If you toss a coin 4 times, then 2 and 2. That is good. That is the expectation. So if you toss a coin 3 times, obviously you will expect the head to come 1.5 times. That is the expectation. 1.5 is not a possibility, but it is an expectation. So an expectation need not be a possibility. Okay. It is not necessary that an expectation is a possibility. An expectation can be an impossible event also. A few minutes ago, we talked about what the value was coming, 2.25, and 2.25 was not among the possible values. Then there was a doubt in your mind that I clarified, but that was not clarified fully. That is clarified right now here. That yes, 1.5 is not the possibility, but it can be the expectation, because if we toss the coin 3 times, then we expect that head will come 1.5 times. Actually, it will come once or twice, or even 0 or even 3, but the it will be around 1 or 2. That is our expectation. 1 and 2 have equal chances. That's why 1.5, because we have to assign a value to the variable that whose value is to be found out. Okay. So this was example 16.27, and with this example I cleared probability distribution, mean, expectation, meaning of expectation, expected value, how to find mean, and how to understand the probability distribution. Now we will do more examples. This is the table and this is how it is found. Okay. Now we have to find its standard deviation also. Okay. For the calculation, x square and x square f in the same table. Okay, don't do extra hard work. It will be 0, 1, 4 and 9, right? X square into f. So 0 and that is 0, 3 by 8, 4 into 3 by 8, that is 12 by 8, and 9 into 1 by 8, that is 9 by 8. This total will be sigma x square f, that is 9 and 3, 12, 12 and 12, that is 24 by 8, that is 3. Okay, so variance is sigma x square f minus mu square, that is 3 minus 1.5 square, 3 minus 2.25, that is 0.75. Okay, 0.75 is the variance, so standard deviation will be equal to root of 0.75. We can write it root of 3 by 4, that is root 3 upon 2, approximately 1.732 by 2, so 0.87. Okay, variance is 0.75, standard deviation is just root, so approximately 0.87. That you can do with your calculator also. A random variable has the following probability distribution. A random variable has the following probability. The probability distribution is already given. 4, 5, 7, 8 and 10 are the possible values. Okay, we draw it this way. 4, 5, 7, 8, 10. 0.15, 0.20, 0.40, 0.15, and 0.10. Okay, this total is obviously 1, but we just cross check. This is okay, 1.0, correct. Sorry. Now xp, this is 0.6, this is 1.0, this is 2.8, this is 1.2, and this is 1. So this will be 6, 1, 1, 2 into 4 into 6.6. Okay, x square is 16, 25, 49, 64, and 100. But let's take a look at the question. Find ex minus ex square, that is it is asking us to find variance. Okay, this is the notion for variance. Remember that. Okay, this is the notion for variance. So it is asking us to find variance. We will find in our own way. Okay, so it has found expectation that we have found already, that is mean, that is mu. Okay, now sigma x square p is our first goal to find. Okay, we'll do that. So these are our calculations. Now it will be 1 and 2, 3 and 5, 8 and 19, 27 and 36 and 46, 46.6 it is. Okay, so sigma x square p minus mu square is our variance. It is 46.6 minus 6.6 square. Okay, sorry, 46.6 minus 43.56, that is 3.04. So our variance is 3.04. Okay, our variance is 3.04. Now it is asking something else also. Also obtain variance of 3x minus 4. So y is equal to 3x minus 4. Standard deviation will be what? Sigma square is 3.04. So sigma will be root of 3.04. Okay. Standard deviation of x is 3.04. So standard deviation of this will be 3 times. Okay. Standard deviation of y will be 3 times root 3.04. So variance will be what? Sigma square y will be square of this. So 9 into 3.04. Okay. That is 27.36. This is change of origin and change of scale that you have to remember. I told you in the chapter 11 uh, statistical description of data, and thereafter it was a central tendency and dispersion. Okay, central tendency and dispersion chapter. In that chapter I told you about change of origin and change of scale. Whenever values are given like this, y is equal to ax plus b, then in case of dispersion changes are done according to this. Okay, so we will change it like, and change it on the basis of 3 multiplied by 3. So sd will be multiplied by 3, hence variance will be multiplied by 3 square. So 3.04 is multiplied by 3 square, that is multiplied by 9. So 9 into 3.04 is 27.36. Okay, now in a business venture, a man can make a profit of 50,000 or incur a loss of 20,000. What is expected? What is expected? What? Profit. Expected what? Profit. Expected what? Profit. So our random variable is what? Profit. Random variable x is profit. What are the different values of profit? Many students will say, sir, there is only one case of profit, that is 50,000. No, because you are studying mathematics right now here, so you have to consider everything. You have to think in all directions, and a loss of 20,000 is a profit of minus 20,000. Okay, so these are the two possible values of profit. Hence it is a random variable x, because if only one value was possible, then it couldn't be called a variable, because a variable must have at least two possible values. Otherwise it is not a variable. Okay, so x can be 50,000 or minus 20,000. Okay, what are the probabilities now? The probabilities of profit or loss are this and this respectively. So profit is 0.75 and for loss the probability is 0.25. Okay, so this is our table. The probability distribution is now complete. Okay, now we have to find expected profit. Expectation means mean, and a mean is what? Sigma xp. We will find x into p. Okay, this is 37500 and this is what? Minus 5000. So the total is 32500. This is our expected profit. See, it is not possible that he makes a profit of 32,500. Either he will make a profit of 50,000 or he will incur a loss of 20,000. Okay, only these two are the cases. That means 32,500 profit is not even a possible case, but still it is the expected value. Yes, it is possible. So expectation doesn't need to be a possible value. Okay, expectation is actually what I did tell you. Say 100 people, like this man, 100 people do the same thing, and out of those 100 people, a few make profit and a few make loss. So the average of profit of all of them will be 32,500, and that is also the expectation. It is not guaranteed that the average will be 32,500 only. It can be anything, 37,000 or 38,000 or 20,000. But this is the expected value. Okay. So whenever these expectations we calculate for a large scale that this experiment is performed 1,000 times. So the average of all will be this. Okay. Then our calculations are justified. Then only. Okay. A box contains 12 electric lamps, out of which 5 are defective. So 5 are defective, 7 are good. A man selects 3 lamps at random. So this is our experiment. What is the expected number of defectives? So expected what? Expected what? Expected number of defective lamps. Number of defective lamps. What was the experiment? 3 lamps selected. 3 lamps selected. So defective lamps can be 0, 1, 2 or 3, maximum 3. Because he selected 3 lamps, so the defective lamps cannot be more than 3 and cannot be less than 0, cannot be decimal also. Now px. No defective means all 3 lamps are selected from the 7 good lamps. So 7c3 by 12c3. This is the probability. Okay. Now 7c2 into 5c1 by 12c3. 7C1 into 5C2 by 12C3. All three defectives 5C3 by 12C3. These are the probabilities. Now it becomes lengthy. Okay. Now it becomes lengthy. But yes, you have to do this. So calculate the probabilities. You will get the values 35 by 220, 105 by 220, and then 70 by 220, and then 10 by 220. Okay, I am constructing this table again. X and P 0, 1, 2 and 3, 35 by 220, 105 by 220, 70 by 220, and 10 by 220. What is the expected number? So let's simplify this at first. It is actually 7 by 44. It is 21 by 44. It is 14 by 44. And it is 2 by 44. Okay. Now XP will be, we just have to find sigma XP because expected number of defectives it is asking. Okay. So 0 into this, that will be 0, 21 by 44, then thereafter 28 by 44 and 6 by 44. So this is 27 and 28, that is 55 by 44. 55 by 44, that is 1.25 obviously. So this is how we calculate expected number of something. Okay, this is actually Mridul. Mridul draws two balls from a bag containing 3 white and 5 red balls. He gets rupees 500 if he draws a white ball and 200 if he draws a red ball. Okay. What is his expectation if he is asked to pay rupees 400 for participating in the game? Would he consider it a fair game and participate? So the participation fee is 400. Let us find expected value which he will get, because we cannot guarantee what he will get. Okay, so we will find expected value. Okay, expected value. If the expected value that he will get is more than 400, then obviously it is a fair game and he should participate. Okay, but if it is less than 400, then he should not. So the entire question revolves around expected value of the sum he will get. Okay, there are white and red balls, so the case can be both red, one white, or both white. Okay, for both white he will get 500 and 500, that is 1000. One red and one white he will get 500 and 200, that is 700. For both red he will get 200 and 200, that is 400. Expected value will obviously be average of these based on probabilities. So between 400 and 1000 somewhere. That means obviously greater than 400. So do we need to calculate the expected value in this question? No, we don't need to calculate. Okay. Because there are three possibilities, and obviously if we take average of these in any possible manner, the average cannot be less than 400. So cannot be less than 400, cannot be more than 1000. Okay, so obviously if the participation fee is 400, he will get at least 400 or more than 400. Okay, so yes, it is a fair game and he should participate. In fact, the game show organizer, he is a fool right now because he will be in a loss definitely, or at least he will gain nothing, because for every participation of 400 rupees he is paying at least 400 back. So in no case he is earning something. So the game show organizer is a fool. Okay. But still, if we want to calculate, so there are three cases: 400 rupees, 700 rupees, and 1000 rupees. 1000 rupees means both balls white. So 3C2 upon 8C2. 3C2 upon 8C2, that is 3 by 28. One red and one white, so 3C1 into 5C1 upon 8C2, that is 15 by 28. Both red, that is 5C2 by 8C2, that is 10 by 28. These three are the probabilities. This is our probability distribution. We can write it like this: x and p. Okay, 1000, 700, 400, 3 by 28, 15 by 28, and 10 by 28. Yes, if it has asked what is his expectation, yes, because of this question we need to calculate. Okay, so x into p will be 3000 by 28. This will be 10500 by 28. This will be 4000 by 28. So this will be 17500 by 28. Okay, 625 is the answer. 625 is the answer. Okay, 625 is the expected value. A number is selected at random from a set containing the first 100 natural numbers, and another number is selected at random from the set containing first 200 natural numbers. What is the expected value of the product? What is the expected value of the product? So expected value of x into expected value of y, that is as simple as that. So first 100 natural numbers, the probabilities being equal, all probabilities are 1 by 100, 1 by 100, 1 by 100. So the mean will be very simple: 1 plus 100 by 2. Okay, that is expectation of x is 101 by 2. Expectation of y will be similarly 1 plus 200 by 2, that is 201 by 2. Okay, so expectation of 1 is here, expectation of 2 is here. So the expectation of product will be this into this. Straight and simple. Nothing we have to do. Because if you try multiplying the all possible cases of 1 with all possible cases of 2, then you will have 20,000 possible options, and that will be very difficult for you. So it is a very easy and simplified formula that expectation of x into y is actually equal to expectation of x into expectation of y separately. Okay, this is a very useful formula. Now a dice is thrown. A die, actually a dice is a plural number. It will be a die when it is singular, because a die, that means only one die, so die will be there, not dice. A die is thrown repeatedly till a 6 appears. Write down the sample space. When you have to write the sample space and you haven't seen this question before, so it is a very difficult question for you. Okay, 6 appears because you don't know how many times the die will be thrown. Okay, so you cannot write sample space precisely if you are seeing this question for the very first time. Okay, so I'm telling you what to do. 6 appears is the case of success. Let us denote probability of success by p. Okay, and probability of failure by q. So q is equal to 1 minus p. Okay, the probability of getting 6 in one throw once, that is 1 by 6, and not getting is 5 by 6. Okay, so what will be the sample space? See, if we throw the dice only once and if we succeed, that is a case, so p, that means we succeeded. Okay, only one throw and we succeeded. The second case, in the first throw we didn't succeed, but in the second throw we succeeded. So first failure and then success, thereafter failure, failure into success, failure, 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 and then success, four times failure and then success, and so on. So this will be P, QP, Q square P, QQP, Q power 4P, and so on. Okay, this is the sample space. Now find the expected number of throws. Expected number of throws. So if the number of throw is 1, the probability will be this. For 2 it will be this. For 3 it will be this. For 4 it will be this. Okay, so this is our expectation of x will be sigma x into p. So we construct this table x, p, and xp, 1, 2, 3, 4, and so on, p, qp, q square p, QQP, and so on. This is P, 2QP, 3Q square P, 4QQP, and so on. Okay, so sigma XP will be this when you take the sum. By taking a closer look, it is an arithmetico-geometric progression. Okay, arithmetico-geometric progression that is out of your syllabus. This question is there for very long in this book, and it is out of syllabus because arithmetico-geometric progression is involved in this. So teaching the entire arithmetico-geometric progression is not feasible, but yes, using the appropriate formula for that progression, we obtain the value of this. We obtain the value of this to be 1 minus q raised to the power minus 2. 1 minus q was already p. So p raised to the power minus 2, that is 1 by p square. So 1 by p. 1 by p. P is 1 by 6. So reversing that, it will be 6. Okay. By thinking decently, by thinking like a sensible person, we can also arrive at this conclusion that we have to obtain 6 once. We have to obtain 6 once, and the die is thrown repeatedly until a 6 appears. So the probability is 1 by 6. The probability of obtaining any particular number, be it 1 or 2 or 3 or 4 or 5 or 6, it is 1 by 6. Okay, so one specific number if we have to obtain, then every 6 times expectedly, okay, I'm talking about expectedly, it is possible that we throw the dice 6 times and all 6 times we get 6, but that is not the expected thing. Okay, so expectedly out of 6 throws we will get a particular value once. So the expected number of throws is 6. Okay, thinking sensibly, we can automatically arrive at that conclusion already without doing this much calculation. We can uh, find this answer that expected number of throws is 6. Okay, so now a random variable x has following probability distribution. This will give you some trouble with the first sight, but never forget that the sum of probabilities is equal to 1. So 7 and 2, 9, and there is 10k square plus 9k, 10k square plus 9k is equal to 1. 10k square plus 9k is equal to 1. That means a quadratic equation. There you get the value of k to be equal to either 1 by 10 or minus 1. Minus 1 is not feasible because that is a negative value. Okay, So k is 1 by 10. By putting the value of k to be 1 by 10, we get the fresh table. Okay. We have to put this here. Okay. We will skip this one because the probability is 0. So 1, 2, 3, 4, 5, 6, and 7. K is 1 by 10, that is 0.1. So when we put this, the probabilities will be 2k, that is 0.2, 3k 0.3, it is 0.1, it is 0.2, it is 0.01, it is 0.07, okay, it is 0.2k square plus k, okay, 2k square plus k, that is 0.12. Okay, so this is our table x and p. Okay, now find the value of k that we have done. K is 0.1. Probability of x less than 3. X less than 3, that is this 1 and 2. So 0.2 plus 0.3, that is 0.5. Done. X greater than equal to 4. We will include 4 also. Greater than equal to 4. So 2 and 1, 3, and 0.4. 0.4 will be the answer. The sum of these is 0.4. Probability of x greater than 2, that means starting from 3, less than equal to 5. So 4 and 5, 3, 4 and 5. This is 0.31. So 0.5, 0.4 and 0.31 are the answers. Okay, so this was your chapter, expected value, expectation, variance of a random variable probability distribution. Okay, if you have any doubts left, you can WhatsApp us on 829-4600-829. Don't call on this number, only WhatsApp. Okay, so thank you so much for watching this video. Don't forget to like, share and subscribe. Please do like, share and subscribe. Please tell your friends. Please press the bell icon, and happy learning. Bye bye. Thank you so much.